We are now in day 2 of YYConf 2013. I am now going to announce our 2 new speakers, Diego and Norbert, and they will be talking about what you're talking
Hybrid
about.
apps.
Hybrid apps. So everybody, give a big hand for Diego and Norbert right now.
Hello, everyone. It's a pleasure to be back here. We're going to talk about a little bit how we build an app in hybrid. I used to using HTML5 and hybrid. I am a Yahoo alumni. I used to work with a lot of you guys. Proud of it. And now I'm working at Salesforce as a UI and performance engineer. And here's my friend Norbert. He works also in performance, but on the backend side, in the dark side, I call it. And we're both wine lovers. And why that matters is because the app I'm going to talk about is the app that we built for wine lovers. So let's introduce really quick, a quick story. This is an anonymous person which is drinking wine in an app. He has this brilliant idea of building an app. And, he's in his drunkenness and say, you know what, we should build an application for this kind of thing. And his friend, which is as lucid as he is, like, yeah, let's make people happy. I mean drunk, I mean happy. Of course, it was us after 7 drinks. So we decided to create Pinot. That's how we call the app. And I think you guys are going to follow more. If you can go to this URL, you can either go with any WebKit device, or if there's an iOS application that we built, and we create an account for you if you want to try it out. We're going to be referencing things on the app so you can see what we did with the app. So feel free during the talk to install it. It's all free. It's all like just to try it out. We don't want to sell anything here. So basically, Pinot is, in a nutshell, is an app that's super visual that we can just scroll across wines and we'll have our collection of wine we can share with people. That's where our goals were with the app. And our main goals, as a front-end engineer, I wanted the app to be fast, and I'm going to apply all the concepts that we saw yesterday and today. I'm going to talk a little bit about that during the talk. And of course, we wanted to tackle as many devices as possible, and Norbert will talk about that.
Yeah. So we wanted to build this app that supports a really rich user experience. And what that means is stunning graphics and also very intuitive gestures. And all the while, we didn't want to compromise on any of the responsiveness of the app. We also wanted to build an app with a uniform experience across all platforms, and also at the same time have a very tight source space where it's easier for just the 2 of us to maintain. So it happens that around the time we were deciding what to use, HTML5 just became the W3C candidate recommendation. And so we took a look at it and we thought it was pretty neat. It introduced a whole bunch of new features, some of which were very critical to what we wanted to build. And to name a few, it's got the CSS3, canvas drawing, 2D animations, local storage, access to the camera, etc. So in building this thing from the early stage, we experienced a lot of churn in the UI design. And we thought that building Pinot as a web app will allow us to do much more of a rapid prototype and to make frequent changes. But as a user, I still feel that there's something special, something unique about being able to install an app onto my device. It gives me a stronger sense of ownership of this app, and it makes me want to come back and re-engage with the app more frequently. So we thought about, hey, what if we built this as just like a native iOS or Android app? But then we don't get to use the cool HTML5 and CSS stuff. So luckily, we found this hybrid approach. Adobe's been maintaining this awesome project called PhoneGap. And we've compared a couple alternatives, but thought that the PhoneGap project to be the most straightforward. In a nutshell, it's basically a simple web container that bundles your HTML, CSS, JavaScript files into an installable app. And it looks no different, and to the user, it feels the same as a native one. On top of that, what's even better is Adobe, they have this online service that's free called the PhoneGap Build. And you don't have to install any SDKs. All you have to do is zip up your source files, submit to the server, and out spits several binaries, one for each of the mainstream mobile platform. So you can get like an iOS, Android, Windows Phone, BlackBerry, etc. Binary.
All right, so let's talk about the fun stuff. There was a couple of talks yesterday really interesting about how to build this hybrid kind of rendering the server and the client. So our approach was pretty different because our app was static. And I think one of the decisions we made, like, let's make everything client-side. So basically our server is going to be only using as an oracle for fetching data and then storing images. That's pretty much it. All the stuff is done by the client side. We ship all the stuff to the client, and we basically build everything from there. So this is pretty much the architecture that we built. YUI, JAF, and then we have our Pinot app. And then basically we have little modules that are tightly coupled together. And then we just have to modify a little bit of component for performance reasons we're going to talk about today. And then a little bit of native kind of provider where we can switch on and off depending on which environment we are. So all of that leads to why we choose YUI and JAF. First of all, because we have a little bit of knowledge in those, but also because, first of all, the dependency manager we've been talking, and Dab was telling before about how we can combo load everything on the fly, and how we can distinguish between the context of we're in web, we're in native. Let's pull that all together. And also, everything is event-driven. So we reuse our components a lot. And we don't want to rewrite for different views. So you're checking the app, pretty much everything is being reused. Another interesting thing when we're writing a single-page application is that garbage collection for performance is super bad. And it's even worse in lower devices like Android from 3 years old, right? So one of the things that we did was reducing the memory footprint. Try to allocate as many things as possible in the beginning, and then try to reuse that as much as possible. So all the models that we use, all the views are all the time one instance that we just reuse, and we just try to minimize that footprint. And then we can override things like the scroller that we need to do for performance reason, or some of the animation that we're going to talk later on, why we did that and how.
Right, so like most apps out there nowadays, we need a server. And when we were thinking about what to use for a server, there were a couple of requirements. We wanted a hassle-free one, which means we didn't want to spend too much time maintaining it. We also wanted something that's powerful such that we're not limited by any kind of functionality. So we compared some of the main offerings. We looked at the Amazon AWS, we looked at Microsoft's Windows Azure, and finally we looked at the Google Cloud Platform. We decided in the end to give the Google App Engine a try. And so, aside from being able to do the typical, data storage, we thought that there was, and also a memcache to front a lot of the caching capabilities. We thought that the image service that Google provides is pretty interesting. It allows us to do real-time, on-the-fly image, resizing. The images that are processed are, replicated and cached around the world via Google's own CDN. And also, they provide this mechanism for us to automatically scale our instances such that, it'll adjust to the peak hours.
All right, so we could have been talking about like how we structured the app, but pretty much it's just a JAF, Yahoo Application Framework with modules and views and handlebars, and there's not much fun there. So we decided to get a little bit more detail in how they render performance. We spend a lot of time in making the scroller smooth. If you go to the app and you go to into any category, you will see there's a scroller there. And we spend a lot of time polishing that because it's one of the main features and we wanted to get it smooth. So we're going to talk about what we found when we're building this application in terms of performance, and also we have to notice that we're building into a native, which means that we're going to embed in a sandbox. We're going to be within a web view where the performance there is a little bit, you have basically one more layer to go through. So that's why we're going to spend a couple of demos, that and also all the capture images that we did on the client side. So one of the first things that we found was transitioning between pages. So this is the code that, by default, the Yahoo Application Framework has for transitioning. And what I mean transitioning is when we go from one page to the other, this transition is kicking in, right? So the problem we had with that is that Eric was using inline block for basically trying to address as many devices as possible and being compliant with pretty much every device. So what happens is for us, that was a little bit tricky because what happens is when you have inline block and you transform the inline block to other things like position absolute, you're creating a boundary for the browser. It was like, oh, you're changing that, so it means that I have to re-render. So what we saw is that we're getting a lot of flashes when navigating between pages. So what we did for that, the good thing is that with Yahoo, we can create our own plugin to put in the transitions, and we can apply our own CSS. So just as a tip, there's a nice article about introducing layer boundary that came out recently about how we can minimize the painting and the re-layout that we have to do when dealing with layers. I'm going to say a little bit more than that in a second. But basically, the good thing, this is just the ugly because there's something that we can address really quickly, just changing the CSS. That's something that might be interesting for you to see, that when you have a line block, moving the two panels together was not the best idea when dealing with the scrolling stuff inside or things that need to, we don't know the position ahead of time. So the bad thing was we've been talking about, we are super constrained when we're talking about performance in the JavaScript environment. Well, we have one thread, and there's been a lot of talking about how to reduce junk and how to reduce flickering. And basically, what we need to do is try to minimize as much as possible how much things do we do per frame, which means that we have to limit our frame rate for about 50 milliseconds if we want to keep 60 frames per second. So I could talk the whole hour about that, but I'm just going to focus on one of the things that we found. So if you notice, we have this scroller that can have hundreds of elements. And then if you look at the web and you think, oh, my page is flickering, you're going to find that, oh, translate 3D all things. Like you put a translate 3D and everything will magically work. And I want to show here that there is super nice tools today to debug that kind of thing. So if we do the translate 3D, which is by default what scroller, like for some most of the scrollers does out there, the page will never run. And the reason is because we're creating this gigantic texture that you have to hand off to the GPU, which, for example, in this case is about 3,000 pixels, 4,000 pixels, and then the GPU will not be able to run it at once, right? So basically the idea will be let's split it in chunks so we can manage those texture processing on the GPU. So the good thing is, again, we're going to show a demo how we can debug that today with some super interesting tools. So if you happen to have Chrome Canary, there's new flags that you can enable. I'm going to put that in the slides. I think I forgot. And basically, we're going to exactly know what's going on under the covers at the GPU side. We're going to see how we can dissect this scroller in this example for seeing how we can improve performance. So if we launch this, you're going to open a regular Chrome Canary. I'm going to open our app. And then what we're going to do is, if everything goes good, we're going to open a new window. And we're going to open the Chrome tracing tools. All right. And what we're going to do is we're going to record what we're doing. And right now, we're going to basically go through here. And then we're going to scroll. And you see that it's loading. All right. So the interesting stuff, at the beginning, it can be a little bit weird to understand this. But after a while, you can see. So in this example, we're going to see to this. Let me see what it is. So my memory is limited, so I'm going to just load one I did before that I know exactly what it is. All right, so as you can see here, this is while we were scrolling the page. This view here will give us exactly what the GPU is watching. Interesting stuff here, as you can see, I'm going to zoom in, right? And if you see, Firefox has this amazing 3D layering, but for dumb stuff. What we're seeing here is the GPU layering. So if we do a 3D amazingly view here, you see that we do not have just one layer, but one layer for each of the images. So the way we achieve this performance on the scrolling is we separate every layer, and we have already 20 or 30 of them. And what we do is reuse them while we're scrolling. So when we have more than 50, what we do is we reuse that, and we just move them across. And this is really similar to the approach that Sencha did for the Facebook kind of HTML5 hybrid. And so I just want to show you one example of how we can achieve really good performance using these tools, where we can show us, and actually if you drill into here, actually will tells you why this is being translated 3D and why it's being composited. So for example, sometimes it's not just good to throw a translate 3D at it. It's just better understand what's going on, and maybe with a setting this or just promoting the layers to a level that the browser can understand better, can we achieve the same performance without having to exhaust the GPU bus, sending texture across the wire. So that's one of the main things that I want to talk about. And I'm going to be talking about probably soon about a tool that I'm trying to finalize and all about re-rendering performance.
Sure. And finally, I just want to show a little bit of what we did with the image manipulation for user interactions. So here's a sample, or basically the gist of the workflow that we go through for posting a new item. If you're running this in a mobile web browser like Chrome or Safari, we'll be triggering the HTML5 camera. If you're running this in the PhoneGap native hybrid app, then it's going to trigger a native plugin, and this is for performance reasons. After the camera takes the photo, we then paint it onto the canvas, and then we allow the user to do some simple manipulation, and we'll go into that in a bit. And then after the user manipulates the image, we then convert that canvas back into a blob, and then we submit that to our server. There's some interesting bugs that we found as we implemented this. That something about on Android, this blob that we submit directly to the App Engine image service, the blob actually gets stripped out, and then we had to go through some we had to jump through some hoops. But the gist of it is basically this simple workflow. So a lot of apps for zooming in and finding a region that you want to actually identify and use as your final image, what they do is they give you a like a dotted line or like a bounding box, and then you would drag in the bounding box to the region that you want. We wanted to create something a little bit more intuitive, so we decided to do something that's sort of the inverse of that. We had a fixed bounding box, and then we allow you to use your fingers and do this pinch zoom behavior. And to give you a little background before I actually show you on this thing, so pinch zoom itself just means that you are taking two fingers and you are dragging 2 points away from each other or towards each other. And what that does is it identifies or indicates what the scale you want, and then we'll display the image either larger or smaller. We also wanted to integrate the pan move behavior, which is while you're pinch and zooming, that you can also move your fingers around at the fixed distance, such that the whole image is moving at constant size, but in any of the directions. So to give you an idea, like if I were to spread my two fingers, but also at an angle, then it's not only zooming in, but also moving it sideways. Yeah, so we on Diego's, we pretty much have the
Chrome version.
The Chrome version, and here we have mine. Can you see that? You can see. So on the black one, it's the PhoneGap build, and on the white one, it's the Chrome version. So I'm just going to try it on mine first. So basically, I'm going to take a photo of you guys. Gosh, I can't really see myself. All right, so this is the of this thing? Yeah. Oh, the phone. How do you do that?
And what if we put it closer? Is that better? What?
That's better? All right, it's not very focused, but you'll get the point. So this is basically this is the bounding box that I'm talking about. So for us, we're not allowing you to move the bounding box, but I could put two fingers on there, and I could zoom in, and I can move it around sideways. Right. And once I get to the image that I want, for our purpose, it would be like a wine bottle or something, then you would just hit Save Image, and it goes through the remaining steps of trying to convert it into a blob array and submit it to our web server. This is basically a tiny little sort of fun project that we worked on.
We did not find anything yet on any project or any open source that it did that all on the client side. So we have a gallery module that we don't have time yet to finish the test. I think after the Arias talk, I'm going to have to run Istanbul and see how my feelings are hurt. And we'll have to tweak a little bit some things, but other than that, next week we plan to open source the, probably I'm going to talk with the YUI to see how we can embrace the stuff for the scroller, and we're definitely going to open source the pinch to zoom image kind of thing. And I think that's pretty much it. So if you guys have any questions, we will happy to.
All right, we're ready for questions. All right, Eric.
So I think it was pretty cool how you were showing those tracing tools. Do you know, is there a way to like programmatically hook into that, like to almost automate that sort of thing if you wanted to do it in CI? Did you see anything like that?
There is, I've been talking to the Chrome team, some of the folks there, and so there's a tool there's a framework that they released. It's called, what the fuck? It's called Web. It's called what the fuck? It's called Web Tracing Framework. Yeah, there we go. And that's, I think, gives you the hearts with some of the stuff. But I talked to them and they say that this is kind of a beta thing. Actually, if you put in if I zoom in a lot and I do crazy things like blackout, or the Chrome just is still on beta, they're working on that, but I think they want to do something where we can inject that in some kind of tool where we can see regressions. There is the tool that they are using on top code, which is the telemetry, which gives you some stuff. But I think the combination with those tools will be, this pretty much is manual. Like, have some bugs at work, for example, that have to check and see like what is the compositing here and why is this getting re-rendered again. And actually, if you see, Aria has a really good post for re-rendering and how you can enable Safari. Maybe I can show you really quick. I don't know if I have the, oh yeah, I do still do. So there's a couple of things that you can do in Safari, for example, that's super visual. I don't know where Safari is. But it tells you, if you go to the Aria's post, it talks about that. But for example, if I go to, I don't know, Pinot, you see these numbers here in these regions. It gives you the times every texture went to the GPU. So you can see, and this has a really good example where you can see how you change different transitions. You can do stuff. So to answer your point, there's nothing that I saw yet for automation, but I'm working on something that can be somewhat automated. I'm working in a way that we can measure the GPU. So I can create a library and tell you, oh, this is an Android with a version 2 point something. Better you don't use any Relay 3D or any images because it's going to be super crappy. Yeah. So I'm working on something like that. I'm probably going to have something soon to show you guys, but there's nothing really that I can hook into. Unless if there's any good C++ I can hook into the WebKit, that would be awesome, but I do not have that skill yet.
And then just one other thing, the way that you were breaking your interface up into these different layers you were talking about and doing, I guess, the translate 3D on those to send these different layers to the GPU instead of one big one. Did you end up developing sort of a pattern or a library or a little mini framework to help you do that, or is it kind of just intermixed within your code?
So I took a scroll view, and basically, for example, one thing is they use the request animation frame, and there's a lot of things. The problem I found with open sourcing or creating a library with that, every use case is different. For example, for the case of Sencha, they created special tiles for the different height and width that they have. So they have two kinds of weights. So they prepare already those like regions that they can reuse over and over. So, and as Self, we're working on something similar, like kind of creating components for that thing. And we found out that every use case is different. For example, if you want to have input boxes, that's different because then you have to interact with, iPhone will zoom in and do kind of weird things around. If you have, different size and different heights, different how you're going to render. So it's really difficult to come up with the scroller, and probably everyone's know here that it's been doing a slider. It's super tricky to get it super performant. So the aim will be to have kind of like set of scrollers, or set of, and then try to getting some component that kind of work for pretty much a broad audience. But I think it's going to be, at least for now, tricky to get like this component that will work across all the devices and all the use cases. So I think something that we definitely want to look into, like either in my free time or like in our work, but there's definitely a lot of things going on in that direction. So.
Thanks.
All right.
Are you accessing the shaders directly? Are you writing shader code, or are you just using default shaders and telling them what to do for your graphics, for your?
You mean for?
When you're sending your graphics to the your graphics accelerators?
Well, no. I'm using here. I'm gonna put the command, the flags if you want to use. I'm just using what Chrome guys are using for debugging stuff at the GPU layer. I'm not using any.
So
I
you're not
didn't do
talking
any
GPU?
magic. No, I just using the amazing work that they did. So the interesting part is like if you go to Aries, there has a really, and into the Google guys blog, there's a really interesting talks about how the WebKit works and how the WebKit is not actually the one who does the work of sending stuff to the GPU and all that. And actually what you realize is WebKit is doing nothing out of it. So every device is different. And this is where we'll have to be really tweaking how we do things. Because that's, for example, Google uses Skia, where iOS uses Core Graphics or something, I remember. So this is the guys that every handling to GPU, every image decoding, every single thing that doesn't to deal with parsing HTML is different, and that's kind of why this tool is interesting for most of the. So if you get it working for Chrome or for WebKit or Blink, most likely it's going to work in iOS. But there's some certain difference. But this tool gives you the whole life cycle of what happens from the V8 to parsing, how it rasterizes, and it's really interesting to see how changing a shadow can impact the performance rendering time, like exponentially, like just putting some shadow 1 or 2 pixels is totally different. So this tool really helps, like analyzing what's the bottlenecks on the GPU. So I did not do anything weird with.
All right, let's have a big hand for Diego and Norbert.